Alright class, this is Ms. Jacoy, so in case you haven't done it yet, go to page 22, open up your large packet, turn to number 4, and try it before going over it with me. Alright, now that you have tried it, let's look at it together. So 1, read the problem. A rock is dropped from rest and falls a distance of 20 meters. How long does it take to fall? How fast is it going to fall in the end? So we see 2 questions. This is a good hint. We're going to need 2 equations. So let's just focus on A for now. So we have a rock. It's dropped from rest. And it falls 20 meters. Alright, that's essentially a picture. Then things we know that its initial position is at 20 meters, and it fell to its final position at 0 meters. So you could call this 0 and this 20, it doesn't matter. However, I like to have my down be negative and my up positive. And I like to put ground as 0, so I'm going to put 0 up here, 20 up here. So it fell, so it did end up essentially dropping from 20 to 0. We want to know how long does it fall, so we care about time. That's our unknown. This is a free fall problem. It is falling, so we do have to use acceleration from gravity. If you can either look it up, or if you wrote it down on your paper, like I told you to last week. It's negative 10 meters per second squared. I am rounding. You could do negative 9.8. We'll give you a very similar answer. Let's see, we also know, it starts from rest. Remember, anytime we say starts from rest, that means our V0 is 0 meters per second. Alright, looking at all of these things, what equation should we use? Hopefully, you can look at your 3 equations that you've written down and be like, aha, it's our first equation, or x equals x0 plus v0 times t plus 1/2 a t squared. So we got our equation from here. We now get to plug in things. We know that x0 is 20 meters. 0 meters is our final. Our initial velocity, because we're starting from 0, is 0, so this whole term goes away. Plus 1/2. Acceleration, which is negative 10 meters per second squared, times time squared. So first you need to subtract this over, so you get negative 20 meters equals 1/2. Actually, we can simplify. 10 divided by 2 gives us 5. It's a negative 5 meters per second squared times time. From here, you got to multiply by your reciprocal, or another way to think of that, we have this 5 over here that we want to get rid of, so you have to divide by negative 5. That meters goes next to it. And multiply by second squared, so you cross all these things out. Anything you do to one side, you must do to the other. So we have negative 5 meters. Oh look, that cancels out. We're left with second squared. Negative 5 divided by negative 20 gives you negative 4 second squared is equal to t squared. Take the square root of both. I'm sorry, that's not a positive 4 because that was a negative. All those. 4 square rooted gives you 2 seconds total. Moving on to B. I'm going to clear everything. Same idea, moving on to B. How fast is it going to fall? We still have that same rock. It's still falling. We found out from the last time that t equals 2 seconds. It hit 0. It started at 20 meters. Alright, so we want to know how fast is it going at the end. So what's our final velocity? So final velocity, we don't know. Initial velocity we know is 0. Acceleration is negative 10 meters per second squared. Initial position is 20 meters. Final position is 0. T equals 2 seconds. So how fast is it going? So when we talk about how fast, that is our final velocity. So you gotta look which equation has a final velocity. There are two, and you could use either. It depends. One requires time. So if you think, oh, time, different problem, different answer, I don't want to use it, use one. I'm personally going to use the one with time. We found time, and this is the easier equation to use. Acceleration times time plus the initial velocity. We know initial velocity is 0, which makes our problem very simple. Negative acceleration is 10 meters per second times per second squared, times 2 seconds. You get to cross out 1 second, just one, so that's seconds left. That gives you negative 10 times 2, so your velocity equals negative 10 times 2, negative 20 meters per second. You could have also used the equation v squared equals v naught squared plus 2a times x minus x naught, but this one looks a whole lot simpler. Hopefully this was helpful, and I will see you tomorrow.